Welcome once again to Maths Clinic series. In this lesson, we are looking at the strand geometry around us, substrand measurement, and we are focusing on vectors. And this is the second video of the series of vectors for SHS 1 Mathematics. Now, our previous lesson, we looked at the intro to vectors. And today we are going to look at how we can represent vectors in 4 different modes. Now, so we're talking about representation of vectors. The first one is called component or column form of a vector. Now, we can represent vector by looking at the x component and y component to guide us or to give us the direction and then the magnitude. For example, if you look at the graph here, we have a point P and a point Q. That means we are at P, let's say Pokuase, and we are going to Kwashiman. Okay, so the direction we are supposed to move is to move some steps on the x-axis and some steps on the y-axis, and we'll get to our destination. And so from the point P, we can move 1, 2, 3, 4 on the x-axis and move 1, 2 on the y-axis. So the vector PQ becomes 4, 2. Now, representing vector in the form of this, where we have x and y components, is what we refer to as column form of a vector or component form of a vector. Okay, so let's do more about this. Let's study more about this. We can also use U to represent the vector. Remember, we said it from the beginning that if we want to represent a vector with a small letter, okay, we can also do so. But in writing it in your book, you write the small letter U and put this bar under it. That shows that you are dealing with a position vector or a vector starting from a point to another point. Now look at this diagrams. We are going to see how we can represent each of these diagrams or each of these vectors in a component form. Now let's say the first one, vector AB, vector AB. That's the red one, or we can call it vector U. Now, vector AB, because we are starting at A and we are moving or we are ending at B, looking at the arrow direction, we will start from the x-axis movement before we go to the y-axis movement. Take note that for component vectors, we always use x-axis or we move x-axis direction before y-axis. So anytime you move on your right, towards your right like this on the x-axis, we say it is positive x, and when you move backwards, we say it is negative x. Take note of that. On the y-axis, when we move up, we are moving on y positive, and when we move down, we are moving on y negative. So that is what we are going to use. So from A to B, I move 1, 2. Then I move 1, 2 to get to my destination. And so the vector becomes 2 positive and 2 positive again for y-axis. Because I did not move backwards. If I had moved backwards, then I would have said negative to the 2. And then when I got to 1, 2, I didn't go down. I went up, and so that became positive as well. Good. Now let's look at the second vector, CD. Vector C, and we are moving towards the point D. Okay. If you choose to go backwards, that means we are not going to get to our destination, because looking at where the point D is, we have to move forward on the x-axis and we move downwards on the y-axis to get to our destination. Good. So how many points can we move? We are assuming that for every measurement, from point C to the point here is 1 unit. That is what we are making reference to, 1 unit. And so we have 1, 2, 3. Okay, on the x-axis, so that's going to give us positive 3 on the x-axis, but we are going to move 1, 2, 3 on the y-axis, giving us negative 3 as such. So that vector will be called vector 3. So 3, negative 3. Now let me do the last one, then I'll let you pause and you do the remaining 2. Let's do EF, vector EF. Let's see vector EF. Vector E, that means I'm at E and I'm heading towards F. You realize that I can move right and I can move left to get to F. So I have to go straight downwards. That means on the x-axis, I'm getting 0. But on the y-axis, I'm moving downwards, so 1, 2, 3, and that will give me 0, -3. Good. So that becomes this. Now you can pause the video for a moment and try for the vector GH and vector IJ. Good. I'm sure you were able to see the GH starting from J and you're heading towards H. You move 1, 2 on the x-axis, but there's no movement on the y-axis. So you're going to say x-axis is 2, while y is 0. Then finally with the IJ, okay, remember I can't move up first. I must move horizontal first before I move vertical. And so I have to go 1, 2, 3, 4 on the x-axis, which gives me -4 because I'm moving backwards. And I've moved up once, and so that is +1. And so the vector becomes -4, 1. I'm sure it makes sense. Good. So that is how we represent vectors using component form or in the component form. Our second representation is going to be magnitude bearing form. Remember, in bearings, we studied that bearing is just a direction, right? And so for magnitude bearing form, or the directional vector, it always comes in the form of r and theta, where r represents our magnitude and theta represent the direction or the bearing from the North Pole. Remember, we learned that our bearings are taken from the North Pole and we move clockwise direction. Good. So if you look at the vector PQ as you see from here, okay, what it means is that the magnitude has been given, or maybe they didn't give us, so I will just use ruler to measure from P to Q. And when I did that, I had 4.47 centimeters. Then the direction from the North Pole, let's call this the North Pole, clockwise, that means from the North Pole clockwise to the direction of this will give us 63. So we can call this vector PQ as 4.47 centimeters and 0.63 degrees. And I'm saying 0.63 because in bearings, remember we said we represent angles in 3 digits, Good. So you see how it works. Now let's do more examples under this. We want to represent the following vectors in magnitude bearing form. So each vector is starting from the point A. So we have point A, D, AB, and AE. Now let's start with AB. The AB. The distance has been given here, which is 4 centimeters, right? And the direction is, we take the direction from the North Pole, right? Always from the North Pole. You're going to move from the North Pole clockwise up to the angle here, and that will give us the bearing. And up to the angle here, we don't know the value, but we know that from the north here to this is 34. So when I subtract 34 from 360, then I'll get the bearing. And so I'm going to write my vector as vector AB as 4 centimeters, 326 degrees. That is if I subtract 34 from 360, then I get my vector. So that vector can be represented in this form. If you had asked me to put this same vector in a component form, I would have said moving 1, 2. On the negative side, I'll get -2, and then moving 1, 2, 3, I'll get that. So what it means is that if I write it in component form, this is what I have. In a magnitude form, this is what I have. They are the same because I can learn I can convert from component to magnitude and vice versa. It's part of the course we'll do in future. Okay, now what about the vector AD? Vector AD. Can you pause the video and tell me how we can represent vector AD in magnitude bearing form? Okay, I'm sure your answer came as, okay, the angle is going to be from the North Pole. Remember, we are always making reference to the North Pole, then we move clockwise. So the angle will be here. But since the whole of this is 90 degrees, we subtract 31 from 90, and that will be the remaining angle here. And so the distance, according to the question, is 6 centimeters. So we are going to write it as 6 centimeters, 059 degrees. Okay, and again, if I want to represent this same vector in the component form, I have starting from a 1 2 3 4 5. So I'll get 5 on the x-axis, 1 2 3 3 on the y-axis. You can convert this and you get exactly the same as that. Then the final one from A to E. A to E, what will be the answer? Pause the video and try and see. Okay, I'm sure your answer came as, did you get the answer? Okay, that's 3 centimeters, 225 degrees. How did we get that? How did we get that? So right from the North Pole, we move up to the line or the vector line. We know here is 90, here is 90, making 180. And when we add the remaining angle, 45 to 180, we get 225. And that gives us the 225. And the distance, according to the question, is 3 centimeters. So that becomes our answer. Now let's look at the remaining two ways of representing vectors. So we've done the first two, the component form and the magnitude form, or the magnitude bearing form. Now I want you to do this exercise. Take a graph book and represent the vector 5 centimeters at an angle of 135 on the graph sheet and label its component for yourself. The third form of representing vector is called the Cartesian form or the standard basic form, which we normally call the IJ form of a vector. Normally we use this for unit vectors a lot. We can just say the x component, we attach I to it, and the y component, we attach j to it. So for example, if I have a vector 7i and 3j, it simply means vector AB is equals to 7 on the x-axis, 3 on the y-axis. So if I put it this way, it is called component form, and if I write it horizontally like this, it's called the Cartesian form or the basic form. Again, I can have a vector like this, and this in the component form can be 1 on the x-axis, -2 on the y-axis. If someone gives you a vector, say AB, and the person writes 3i, just 3i, what it means is that the vector AB has the initial of A heading towards B in the form of 3 on the x-axis, 0 on the y-axis. That is why the j didn't come. So it's more or less we are writing it like this, which of course 0j is the same as 0, so we don't write it. This is the form of a form we call Cartesian form of vectors. The final one is called geometric or graphical representation of vector, and we've seen that already. Anytime we have the vector in the graphical form like this, or like the one we saw earlier, they are called graphical representation. And so in a graphical representation, we can write our component form. We can also convert graphical representation into magnitude bearing form by looking at the angle here and the distance from A to B. And so we can write vector in 4 different ways, and we can convert from one form to another. No problem with the conversion. I'm sure this has really helped you in understanding how to represent vectors. The final thing we have to do is an assignment I want to give you. And the first assignment is that you pause this video, okay, and then you answer the question. Write each of the following vectors in the component form. For example, you have vector AB, okay. Now vector AB, that means we are at A and we are heading towards B. What will be the vector in the component form? It will just from the A we have 1 2 3 4 5 6 7. Then we move 1 2. So we have 7 on the x-axis, 2 on the y-axis. So that vector becomes vector AB. Do for the BC and AC as well. Then finally, if you finish, express the following vector in the component form at the same time magnitude bearing form. This is your final assignment, which when you finish you can submit and give it to any of your teachers to see whether you've done it right or not. Thanks so much for watching.